Okay, here we go. Problem number 3. So we're starting with x squared minus 4 over x plus 2, which factored and reduced. And it reduced down to something linear. So this graph is actually going to look a lot like a linear function. But there are a couple things that'll be slightly different about it, okay? So because there's no longer a denominator, there are no remaining domain restrictions, so there are no vertical asymptotes. And because this was top-heavy at the beginning, higher degree on the top than the bottom, there was also no horizontal asymptote. So we got to skip the step about figuring out if it crosses the horizontal asymptote or not. That no longer applies because there is no horizontal asymptote. There is, however, a hole. And that's because right here, the x plus 2's cancel off. So at x equals negative 2, I have a hole. To get that y value, we plugged it in right here to get negative 4, okay? So there's no HA or VA to graph, but there is a hole at the point negative 2, negative 4. So you want to draw that with a nice big open circle so you know that it's not a filled-in point. Okay. Next, I have a y-intercept at 0, negative 2, so I can plot that point. And then I also have an x-intercept at 2, 0. Okay. Now, normally we would be trying to draw branches that match up with our vertical and horizontal asymptotes. But because there are no asymptotes, this is going to look like a fairly continuous graph, except for this one hole right here. And again, these look like they're creating a straight line, and they are in fact creating a straight line because it's the graph of y equals x minus 2, just with that hole. So we can actually just draw a straight line connecting these, like so. So, if your rational function reduces down to something linear or quadratic or polynomial, then the graph will look exactly like that linear, quadratic, or polynomial function. The only difference is there are likely to be holes involved, but everything else will look the same as it would according to whatever function you end up with. Okay, so that's how I graphed problem number 3.